Welcome to the workshop. I'm Vinita Silaparasetty. We will follow this framework to learn the best practices for conducting an EDA. Begin importing the libraries, loading the data, and generating a profile report. First, let's drop irrelevant columns. In the data dictionary, you might have noticed that under artist 3, the first 5 values are none. Now this is not the same as nan or null. When you use isNull, it will not be detected as a null value. Duplicate rows, we have 2 of them to remove. We will do this by using df.drop_duplicates. We may consider shortening names by creating a function that accepts the entire name as a single string, then splits that string into the forename and the surname. If the name count is 1, that is, if only one name has been provided, then the function returns the first name as it is. Then it abbreviates the surname by taking only the first characters. Pro tip: when dealing with data that contains names, it is best to identify the salutations, that is Mr., Mrs., the forename, and the surname, as well as any initials, and split these into their individual components. Let's apply this function to the columns artist 1, artist 2, and artist 3. Under date time, we have been provided with the year, the month, the day, as well as the exact time. This is simply too much information in terms of time, which could get cumbersome during our analysis. We will extract just the year and work with that. We're going to use a lambda function here. Now let's focus on transforming values in the duration column to minutes. We will do this by using df.duration.apply. We'll use a lambda function once again. Pro tip: lambda functions allow us to create custom mathematical functions with a single line of code. We can see that across all the bars in the bar chart, we have 612 values, but the column time signature has only 607 values. That is where the missing values are. Now we're going to focus on filling in those missing values that we saw in the time signature column. We will do that by saying df of time signature, that is calling the series in particular, and manually filling it in by saying fill NA and then imputing the mean of the time signature series in our pandas data frame. Let's set in place to true. Print a simple statement, time signature, and then print a boolean value for df time signature.inis.isNA.values.any. Pro tip: impute with the median value if the data has high skewness. It's time to check for outliers. We will do this by generating a scatter plot to get an idea of how the data points are dispersed. We are going to plot each of the features against the attribute artist1. Now to make our work easier, let's just copy and paste these 2 lines of code 9 more times. After that, we are going to change the names of the features. Ensure that you spell the feature names correctly. Pro tip: when it comes to outliers, the objective is to minimize them. Removing them entirely may impact the results negatively. Pro tip: it is a good practice to always conduct one final check for outliers before you start studying the relationships between different variables. That's why we are checking for outliers as the final step of the data cleaning process of our current analysis. From the scatter plots, it is evident that there are a lot of outliers. For our data set, the best way to handle outliers is to use a filter. We are going to create a new version of our dataset in which artist 1 should have been mentioned in at least 5 songs to be eligible to be in our dataset. Let's call our new dataset df1. Now let's overlay the scatter plot for df1 on top of df to see how effective our filter is. The outliers have significantly reduced and the data is now ready for analysis. Let us do a study on artists and their qualities by first separating the solo artists. We then gauge the popularity of the solo artist by the number of tracks they have produced. Now let's take a look at the top 10 solo artists. Let's create a bar chart to get a clear understanding of which artists are the top 10. We'll rotate the X labels horizontally so that we can read the artist names clearly. The top 3 artists are Preslava, Zena, and Maria. And the 10th most popular artist is Desi. Let's compare the vocal content songs by Preslava, Zena, and Maria. To conduct a comparative study, we will plot the first scatter plot, which contains all songs that mention the artist. The second scatter plot will be only solo songs by the artist. And finally, we will plot a reg plot, which is a simple linear regression model. Pro tip: sometimes a simple black and white graph can be very effective. We'll print the labels as 2:30, 3:0, 3:30, 0, 4:30, and 5:30, and 5:0. and we will say scatter is equal to false. If we don't put this setting, then we're going to get another scatter plot. Pro tip, you can use an IM plot in place of a reg plot if all you require is a simple linear regression plot. Preslava has more vocal content, Zena has less vocal content, and Maria is in the middle. Let's see what is so different about Zena's music and Desi's music. To do this, we will generate scatter plots once again. Zena has less vocals in solo songs, but more vocals in collaborations with other artists, whereas Desi has a negligible amount of vocals, solo songs, and only appears to have vocals when it comes to collaborations. Now let's take a look at the correlation between liveness and artist. In this case, we are only interested in artists who are mentioned as artist 1. We only want to know who the most popular live artist is, so we do not need to use the reindex function to arrange all of the artists in ascending order. Pro tip, when generating bar plots, keep the design simple and avoid grid lines unless absolutely necessary. We can see that Tatiana is the artist with the most live songs. Now let's study the correlation between each of the variables and see which variables. We will plot a global heat map for all of the features. Let's call it HM for heat map, and we'll use the core function, so df1.core. Pro tip, correlation does not always equal causation. For example, if we see people carrying an umbrella, we don't say that it rained because people were carrying an umbrella, but we can say that people were carrying an umbrella because it was going to rain. The heat map that we generate gives us a Pearson value, and therefore only values which are greater than 0.5 are of interest to us. According to the heat map, we can see that energy and loudness are at 0.7. So that means they have a really strong correlation. According to Spotify, loudness is an argument in the energy function. Let's take a closer look at the codependency of loudness and energy. To do this, we will generate a joint plot where the x-axis will be energy and the y-axis will be loudness. We'll set kind to hex. We can see that the data points are quite close together. So to make a good decision on how to go about binning the data, let us first look at how many unique values we have in the column year. We are going to bin our data in pairs, meaning all the songs released between 2014 and 2015 will be one bin, which we will call the old songs, and all the tracks released between 2016 to 2017 will be in the second bin, which we will call the transition bin. Finally, all the tracks released between 2018 to 2019 will be in the third bin, which we will call the new songs, as they were the latest songs to be released. Pro tip: bins should include all of the data, even outliers. If your outliers fall way outside of your data, consider lumping them in with your first or last bin. This creates a rough histogram. Now let's study the changes in individual features over time. Before we do this, we are going to drop the columns instrumentalness, liveness, and time signature. Remember, we need to drop them from all three bins that we have created. Let's copy and paste that 2 more times, and this time we are going to change the name of the variable for the second one to transition. So to continue with our study of each individual feature over time, we are going to first generate empty subplots. We're going to need 6 of them, and let's arrange them in 3 columns. KDE plot, we're generating a KDE plot. And to differentiate between our KDE plots, let's set the first one to Inferno. You could even keep all 3 color schemes as the same, because we are putting labels for each of the subplots, so it depends on your preference. Pro tip: CMap does offer more options, so feel free to change the color options. We're going to set them as more legible timestamps, so that's 2:30, 3, 3:30, 4, 4:30, and 5. Each of the plots hovers around the 3:30 mark, primarily around the 3:30 mark. We also notice that the changes between the features is very subtle between 2014 to 2017, and then there's a sudden change in 2018 up to 2019. We can also say that the songs fall into 2 main subcategories under tempo, where central point is 125, and we have some songs that are greater than 125 and other songs that are lower than 125. I hope that you benefited from today's workshop.